What is current? Current is a flow of electrical charge in a circuit. This charge is carried by moving electrons in a circuit. Most of engineering students first encounter direct current DC, which is just electricity flowing in a constant direction. An everyday product we use such as batteries have DC in them, hence electricity flowing from a positive to a negative terminal. However, DC isn't the only type of electricity we use. There are some sources that produce AC alternating current, such as a synchronous motor. AC is basically switching current back and forth, and it doesn't make sense as to why someone would use AC over DC. However, with AC, we can build motors, generators, and power distribution systems that are far more efficient than DC. Therefore, AC is now used more widely in high powered systems. In an electrical circuit, we can differentiate between AC and DC by their symbols, as you can see below. When AC flows in a circuit, there are three important things that we need to consider: resistance, inductance, and capacitance of the circuit.
The mathematics behind alternating current in electrical networks. The voltage within an AC circuit is strictly dependent upon the resistance, capacitance, and inductance of the circuit. The first diagram is a graph representing a resistor with a resistance of R. The voltage across the resistor is calculated through the formula V equals IR sine omega t. The second graph is a representation of a capacitor with a capacitance of C. The voltage across the capacitor is calculated through the general equation V equals bracket I over omega C bracket sine bracket omega t minus a half pi. The last diagram is a representation of an inductor with an inductance of L. The formula for voltage across the inductor is V equals omega L I sine bracket omega t plus a half pi. In a general LCR circuit, the impedance Z of the circuit is calculated through the resultant voltages of each component as well as the application of complex numbers. The complex expression for a resistor, capacitor, and an inductor are as follows. V equals R for a resistor, V equals minus J over omega C for a capacitor, and V equals J omega L for an inductor. Using the complex expressions just explained, the total complex voltage is easily calculated through the summation of these voltages. Therefore, the formula is as follows. V equals IR plus J omega Li minus Ji over omega C equals Iz, which simplifies to Z equals R plus J omega L minus J over omega C.
Alternating currents are present throughout everyday lives. They are generally used in generators to transport electricity long distances without losing too much energy due to electrical impedance within the power transmission lines. Once the electricity is delivered to a substation, it is then converted into direct current to be used in households and workplaces to power electronics. Alternating currents are also used in AC motors to create mechanical energy from electrical energy and are commonly used in equipment such as clocks, timers, and air compressors.